Hi students, welcome to the next topic from gravitation. Last class we have discussed about Newton's law of gravitation and certain applications, certain problems we have solved. In today's sessions we are going to see another few areas which are related with Newton's law of gravitation and gravitational field intensity. So let's start the continuation of Newton's law of gravitation, the next topic, which is called superposition principle. So please write on the heading superposition principle. Superposition principle. Superposition principle is all over there in most of the chapters in physics, and which are related with something called vector additions. Okay. So superposition principles means we know the Newton's gravitational formula G m1 m2 divided by r square. If two masses are there, m1 and m2, and they are separated by a distance of r meter away, then the attractive force between the two bodies is given by G m1 m2 divided by r square. What is this superposition principle is talking about? If you have multiple bodies are there, multiple bodies means greater than two bodies are there, then the contribution of force given by two bodies can be added up together. I will take an example. Look into the board. We will do this with an example. We will do with a problem. Okay. Suppose there are two gravitational forces will be here. Suppose you are assuming there are two gravitational forces will be here. So 3 cases I am dealing. Two gravitational force, one gravitational force F1 in the direction, another gravitational force F2 in the direction. Then the resultant force Fr will be equal to F1 plus F2 because both are vector quantity pointing in the same direction. Second case, if two vectors F1 in the direction and F2 in the reverse direction, then the resultant force Fr will be equal to F1 minus F2 if F1 is highest value. Okay, then F1 direction is same as the Fr direction. If you are doing F2 minus F1, then F2 direction is same as the Fr direction. So, and if the third case, if F1 is pointing in this direction and F2 is pointing in this direction and angle between them is theta, then in that cases the resultant force is equal to root of F1 square plus F2 square plus 2 F1 F2 of cos theta. This is the basic formula to find the resultant of two forces if they are making some angle theta. In this case, what is the value of theta? Theta is equal to 180 degree. In this case, theta is equal to 0 degree. Now, if you substituted theta equal to 180 degree will be here, what you will get? Cos 180 is minus 1. So, this is a general formula. Both are opposite direction means theta equal to 180 degree. If you substituted 180 degree in these equations, what you will get? What you will get? Root of F1 square plus F2 square minus 2 F1 F2 because cos 180 is, the reason is because cos of 180 degree is equal to minus 1. Cos of 180 degree is equal to minus 1. Because of this one you are getting. So this is like a square plus b square minus 2ab. So this can be written as root of F1 minus F2 the whole square, which is equal to F1 minus F2. This is what we have written here also. Now we'll go one step above. So in this case, root of F1 square plus F2 square plus 2 times of F1 F2. Why? What is the reason for this one? Cos 0 is equal to 1. So cos 0 in this equation, if you substituted 1, you will get this one. So this is same as what? Root of F1 plus F2 the whole square, which is equal to F1 plus F2. So this is what we got it here also. So this is a very basic fundamental principles in vector addition in physics. In short, I am saying if two vectors are in same direction, you just add it up. If vectors are in opposite direction, you subtract one from another. If two vectors are making some angle and the angle between them is theta, then you apply this formula and you got the answer. The same thing we are going to apply, or we are going to use it, will be here in order to answer for this question. Okay, so this is a basic principle, fundamentals in vector additions. Now we will see how we can make use of this concept while we are solving the problem. We will take an example and then we will solve this one. Okay, fine, perfect. So let me take a question will be here, and based on the question we will solve this one. The question is, three bodies are located at each corners. You have to write the question on your notebook. Three bodies are located at each corners of of an equilateral triangle, of an equilateral triangle. Find the force experienced by the body at C. Find the force experienced by the body at C. So we have the diagram A, B and C. Here we have one body whose mass is m. Here we have one body whose mass is m. Here we have one body, mass is m. Side length is A. Question is simple. Find the force experienced by the body which are placed at the find the force experienced by the body at C. So at C means you have to look it only into C. You are not supposed to look anywhere. So now I am going to solve this question. Okay. So I am answering this part. How I can answer? So I will redraw the diagram as such, like this. So here my body is C. I am interested here. This is A and this is B. So I am interested. I know the side length are A. This is already given. So how many forces are experienced by the body C? By the body C, gravitational force is an attractive force. It's not a repulsive force. Attractive force means that body is moving towards another body always. Attractive nature. So that's the concept will be here. C is the body. C is the body attracting towards the body A. C is the body attracting towards the body B. So that is a true attractive forces are there. This is one of the force and this is the another force. So F1, F2 I am marking. Now what is the value of F1? F1 will be equal to Newton's law of gravitation, G m1 m2 by r square. M1 and m2 masses are same. All are body having the same mass called m. So what is the formula? G m square by a square. A is the distance between them. A equilateral triangle. What is the value of F2? F2 is also equal to G m square by a square. Now my situation is like this. I have one force in this direction F1 which is G m square by a square. I am taking this as F. Then another force in this direction F2 that is also equal to G m square by a square. Both are equal. So I am giving a common symbol called F. Now these two are making an angle of 60 degree because it is an equilateral triangle. In an equilateral triangle each corners are 60, 60, 60. Total is how much? 180 degree for a triangle. So this is like 60, 60 combination. Now there are two forces. How to find this is our two vectors. Again this is a vector, again this is a vector. How to find the resultant of two vectors? Yes, we know the formula. R equal to root of a square plus b square plus 2ab cos theta. Same formula we are applying will be here, which means f1 square plus f2 square plus 2f1 f2. What is the angle between them? Cos 60. What is the value of cos 60. Cos 60 is equal to 1 by 2. Cos 60 and sin 30 are same. Standard values. Cos 60, 1 by 2. So we'll substitute will be here. F1, F2. All I have given, both are same. I have given a common symbol called F. I am replacing with F's. F square plus 2F square into cos 60 is 1 by 2. 2 get cancelled. So it become 3F square will come. 3F square means root 3 times of F is outside. So in specifically root 3 times of, what is the value of F? F is gm square by a square. This is a best example for a superposition principle. I applied the superposition principle. Superposition principle indicate if you have a multiple bodies are there. If you have 2 bodies, then there is only one force. If you have 3 bodies, then you have 2 force. If you have a 2 force will be there. If 2 forces are acting in the same direction, you can directly add it up, F1 plus F2. If 2 bodies are acting in opposite direction, you have to subtract one from another, F1 minus F2. If 2 bodies are making certain angle, then the resultant of the 2 vector is equal to F1 square plus F2 square plus 2 F1 F2 cos theta. Theta is the angle between the 2 vectors. So any one of this method we have to use it, and we have to substitute here to find out the answer. Here you can see there are 3 bodies are there. So 2 forces will be here, F1 and F2. F1 we calculated, F2 we calculated. I got 2 forces. Now how to find the superimposed force? Superimposed means is something called the resultant force. The resultant is called superimposed. Okay. Superimposed. So you can apply superposition principle in any vector quantity. It's not only for Newton's law of gravitation. Wherever you see any vector quantities which have 2 vectors quantities at the same time is coming, you want to find the resultant of the 2 vector quantity, you can use the superposition principle. So this is quite important to know. Okay, so let's do another question. Find the gravitational force between the below given bodies. First, it's a rod having length L, mass capital M. There is another point body M which are at a meters away. So how to find out the gravitational force? 2 bodies, so there is only one force. I need to find out only one force. Find the gravitational force between the below given bodies. This is a rod having length L and a point mass M will be here. I know gravitational force is a central force. So what we will do? We will take the center position. So what is the distance from this body to this body? It is A plus L by 2. So I will apply the formula. I will got F is equal to Gmm divided by A plus L by 2. A plus L by 2 the whole square. If you answer like this one, then this is wrong. If you answer like this, then this is wrong. This is not the correct method. Why? Look here. This is a combination. If this is 2 point masses, like small, this M is a point mass and this small m is also a point mass, then you can apply this formula, you can find the answers. If 2 are a bigger blocks, then you can find the 2 center position. Last class we have solved this question. If you go back to couple of pages on your notebook, you can see some questions. Some questions we have solved with a certain block like this model of question. This is one block with this is next block. This is another model. So this is like M2 mass and this is like M1 mass. Then we will take the center and we can find this one. So this is like two large bodies. This is like two large bodies. But the situation here it is different. This is like one point mass with another bigger mass. One point mass with another bigger mass. Whatever I am writing in the note in the board should be there on your notebook. So if it is one block with another point mass, then the situation is different. Why I am saying the situation is different in the sense M will be here, M will be here and capital M will be there also. So in this context, what we have to do? See, if you are moving from A to this point, one gravitational force A plus some distance will come in the denominator. F is equal to G M1 M2 by R square. So already A is the minimum distance and you have to go to up to L. From this end to this end, the gravitational force is changing. Why it is changing? Because the R, distance between the two bodies, initially this distance, then distance increases, then distance increases, then distance increases this much. So when the distances keep on increases, gravitational force is changing. So there is some tendency to change based on the distance. In this context, what we will do? What we can do in this context? We will consider a small mass will be over here in this context. It's a special case, for example. So this mass is at a distance of x meter away and his mass is equal to dm. So there is a small force given by df will be equal to g into dm into m whole divided by x square. But to get the full force, I need to integrate. From where I have to integrate? A to A plus L is the maximal length. So A to A plus L. So this can be written as Gm divided by x square integral A to A plus L into dm. What is called a dm? Dm is a small mass out of m unit, and which is at a distance of x meters away, So dm is a mass of the small unit and whose length is equal to dx. Now listen very carefully. L meter length will have m kilogram mass. Correct. L meter length ഒരു പീസിന് m kilogram ആണ് അതിൻ്റെ weight. So 1 meter length in how much is the mass? M by L kilogram. L which both sides I am dividing. L which divided here, L is divided here. So 1 meter length in the mass, 1 meter length in the mass. So dx meter, dx is the length we have, which means a dx meter length in the mass, how much? M by L into dx kilogram. That we need to substitute. So now dx meter length in the mass, which nothing but that mass is called a dm mass. Correct? 1 meter, L meter wire will have m kilogram mass. 1 meter wire will have m by L kilogram mass. Dx meter wire will have both sides multiply with the dx. Left hand side multiply with the dx, right hand side multiplied with the dx. So what should I get? M by L into dx. Dx meter length in the mass, which means dm mass. Now for this dm I am substituting integral A to A plus L gm divided by x square dm m by m nana capital M by L. M by L into dx. M by L into dx. Hope you understood how we will get M by L into dx. Okay. Now we'll further simplify these steps. What are the terms? We can take it out of the integrations. So G is common, capital M is same, small m will be the same in the numerator. Denominator L. Integral A to A plus L dx divided by x square. dx divided by x square. We are integrating this one. X square will go to numerator x power minus 2. What is integral x raised to n into dx will be equal to x raised to n plus 1 divided by n plus 1. So in our case x will go to numerator. So we will write gmm divided by L into x power minus 2 plus 1 divided by minus 2 plus 1. Why I am saying means x square will go to numerator. So these steps, this will becomes as x power minus 2 in the numerator side. Numerator. So x raised to, now the formula become x raised to minus 2 into dx will come. So in that case is x raised to minus 2 plus 1 divided by minus 2 plus 1. This is what it's coming over here. Okay. So we are integrating, we are limiting from a plus l. So g capital M small m divided by L minus 2, minus will come, will be here. X power minus 1, which means 1 by x. We are applying the limit a plus. So minus of g mm divided by L into, we are applying the limit 1 plus a by L. Upper limit, integration, after integration we have to apply the limit 1 plus a plus L minus 1 minus a. This is integration method in the standard formula. Integral x raised to n. Okay. You know the differentiation. D by dx of x raised to n equal to nx raised to n minus 1. This is differentiation. This is integration. So we are doing an integration because it is changing. It is changing means what is changing? Force is increasing. If you are moving away from this distance, the distance changes, force is also changes. If your distance is reducing, force is increasing. If you are moving away, distance increases, force reduces. Vice versa. Inverse relation. So once you apply the integration, this is called limit of integration. Lower limit, upper limit. So after integrating, you have to substitute, will be here. Upper limit minus lower limit. Okay, now we'll simplify this. Minus g mm divided by L into, this will get a minus L divided by a into a plus L. Here a get cancelled, minus L become, together become plus L. So this L and L will also get cancelled. So a minus L. So this will get cancelled, minus will get also cancels. So what will comes as an answer? G into capital M small m divided by a into a plus L. This is the answer for this question. Okay, this is like a special cases. This is not comes as a what can I say? It's not a single case. But if it is a point masses, we know it's a gravitational point mass, right? We know it's a g into m 2 by r square. So 2 point masses we have seen, and 2 bigger block also we have seen in the last class. Now this is a combination of a point mass with a bigger mass. So 3 cases on your notebook. 2 point masses, G(m1 m2 by r square), fundamental principles in Newton's law of gravitation. Second case is 2 building blocks, 2 large blocks. If there are 2 large blocks or 2 building blocks will be here, then you have another formula. You have to find the central distance, center to center distance, because it's a central force. Then the third case is like a bigger block with a smaller block. Okay. Bigger block with a point mass. So this case also we have seen now. Okay, so this is all about Newton's law of gravitation topic, and we are entering to the second topic from gravitational law, that is something called field strength or acceleration due to gravity. So let's go ahead. And we are going to see gravitational field strength. You can write the heading gravitational field. Gravitational field. Here I am representing using a letter called E. E is a vector quantity. What is called a gravitational field? Listen here. I have a mass called capital M located over here. I have a mass capital M is located over here. So the point is like there is a border line will be over here. Okay, I have something called some test mass. This is called a test mass. Test mass. So if the test mass reaches the border, okay, so I am writing test mass reaches the border. Reaches the border, what will happen? Capital M pulls the mass M. The mass M. Small letter M in attracting. Which means this is a border line, right? If any bodies which are coming, if it is very far away, then F is equal to G M1 M2 by R square. R is too much bigger, F is very low. Very low means negligible. If it is R is kilometers and kilometers away, then F is negligible. But whenever you are bringing some mass slowly, your test mass will be here. You are bringing slowly. Whenever it reaches the point of this red border, this is a border given by the capital M. And the capital M saying A, if somebody is crossing my border, I will pull it, I will attract it. So there is a region, listen my word, there is a region around the capital M where gravitational force exists. That region is called gravitational field strength. Okay, so I am defining this one. Gravitational field means it is the region around a mass where gravitational force exists. Gravitational force exists. I'll tell you a practical example. You already seen like football matches. You already seen like a cricket matches, right? Cricket ground, it's a border. Football ground is a border. In cricket ground, whatever umpire is telling about you, if it is out, if it is 4, if it is 6, that's a final word. In a football matches, if referee is telling whatever it is, whether it is a foul, then it's a foul. That's all. Because referee is placed certain rules will be here. If you are a person entering into the ground, then you are ready to obey the rules and regulations given by the referee or the umpire. That is the area where certain rules are exist. So that is a cricket ground. We say cricket ground. We'll say football ground. Here I am saying electric field area. Like that. Out of gallery, you can do whatever you want. In the gallery, you can do whatever you want. Out of the gallery also, you can do whatever you want. But when you come to the stadium, when you come to inside the ground, you have certain forces are experiencing. You can't do your own wishes. Somebody is telling something you, and you have to obey to the rule, and you have to act it. That's a simple principle is also working here also. Okay. So whenever you are entering to certain region, you should obey certain rules, which means an attractive force will start to appear. That area is called, this area, I can say this area, it's called the gravitational field area. Okay, this is called the gravitational field, E area, gravitational field area. Now, what is the definition? Now we know this a definition is a region around a mass where gravitational force exists. Now, what is the definition of E? E is equal to F, attractive force between the two bodies divided by test mass. This is important. This is called a test mass. Okay. Now, we'll apply the formula. Two bodies G, M divided by. Suppose when it reaches the border, the distance from the border is R. Distance from the border is r. So gravitational field intensity formula, E is equal to F by m. M is called the test mass. You applied mass formula, you applied m formula, both will cancel, and you got gm by r square. And this is what? This is the field given by, who is given by this? A field given by capital M. This is a field given by capital M mass. So we got the formula for gravitational field intensity, and this is a gravitational field intensity, and the field given by whom? Field is given by the capital M over the test mass. E is equal to gm divided by r square. So hope this is clear. Okay, so now we will see one question. Gravitational field is also a vector quantity as like gravitational force. So both are yielding a vector directions. So gravitational force is an attractive force. Gravitational field is also an attractive kind of nature because it's a force by mass. Okay, force by the test mass. So what is the directions holding by Newton gravitational force? The same direction is given by the other bodies too. So let's do one question and we will see. Okay, the question is like, two bodies of mass m and 9m respectively, 2m and 4m respectively. Distance between them, the capital distance between them is 9 meter. At what distance from M, gravitational field intensity is 0. Gravitational field intensity is 0. At what distance from the area? Two masses will be given, m1 and m2, which are called m and 4m. Distance between them is 9 meter. At what distance from m, gravitational field intensity is 0. This is a question we are going to solve it now, and let's have a look. So we have two bodies. We are answering it. First body called m, second body called 9m, which are separated by a distance of 9 meter. At what distance from m, gravitational field intensity is 0. I am assuming the point will be here. See, gravitational field intensity is attractive or repulsive? It's attractive, right? It's attractive. So in this case, I have three options to take a different point. One is left side 1 another position, one is somewhere in between, that is 2, one is somewhere in right m. Okay, I am saying the point 1 is not possible. 1 is not possible means I will say if there are two gravitational force will be here. See, gravitational force is if I considering one point, from that point gravitational force is attracted towards the body. If I considering point number 1, then m will be here and 4m will be here. So from this point 1, there is an attractive force towards this mass and there is an attractive force towards this mass. So there are two gravitational field intensities, E1 and E2. E1 and E2 are in the same directions. So one gravitational field in this direction, another gravitational field also in the same directions. If two vectors are in the same direction, definitely we will get added it up. So we will never get 0. Okay. So definitely here ER is equal to E1 plus E2 exist. It will never 0. It will never 0 because one vector 5 Newton. force, another vector 2 Newton force, both are acting in the same direction. What you will say, total force 5 plus 2 7, it will never 0. There is no chance to become 0. So it will never 0. So the point 1 not possible, the point 1 not possible. Next, let me take the other point. What is the other point? Other point is 2 will be there. 2 is possible. Before that I am going to 3. In 3 cases m will be here and 4m will be here and 3 is a point will be here. So this is attracted and this is attracted towards the body, and this is our E1 force, our E2 field strength. So these cases both will get added up, and the same case is applicable here also and here also. So the point 1,3 not possible. But if you look into the point number 2, you can see one gravitational force field strength E1 in this direction attracted, and this we have a chance called E2. So 2 is possible. 2 is possible. 2 is possible because there is a chance that ER equal to 0. There is a chance that ER is equal to 0 is given in question. This is given in question. What is that? ER will be equal to E1 minus E2, upper value minus lower value. Upper means higher value minus lower value. So this is possible. So point 2 only is possible, 1 and 3 is not possible. So definitely the point in between these two bodies, distance between them, at what distance from the gravitational field intensity become 0. So we got an idea saying that definitely the point is in between the two bodies, not the right side, not left side, definitely in between. So now this point 2 I am assuming x meter away. So what is the balance distance? 9 minus x. I am sorry. So E1 is equal to gm by, at this point, gm by x square, and E2 will be equal to g into 4m divided by 9 minus x the whole square. So resultant ER will be equal to E1 minus E2, higher minus lowest. Here this lowest term, the highest term. Okay, so which means gm by x square, anything. Anyway, you can place it E1 minus E2, no, E2 minus E1, no, both ways it is same. Anyway, both are going to equate with what? 0. 9 minus x the whole square. This is given as 0. Okay, then that is the case. Gm by x square is equal to g into 4m divided by 9 minus x the whole square. Gm cancels. So what will come? 1 minus x square equal to 4 divided by 9 minus x the whole square. Both the sides we are taking this square root. So what we will get? 1 by x is equal to 2 by 9 minus x. 1 by 2 is equal to, so we are multiplying. So 9 minus x equal to 2x. So we'll got 3x will be equal to 9 and x is equal to 9 by 3, which is equal to 3 meters. So which is equal to 3 meters. So the x value, so at x is equal to 3 meters away, at x is equal to 3 meters away, the field is equal to 0. So I can write an additional point at x is equal to 3 meter from m, the gravitational field, FIELT, the gravitational field is equal to 0. So this is one part from gravitational field intensity. So hope this is clear to you, gravitational field intensity. So today we have learned about 2 topics. One is the superposition principles, and we have done one question. Then we have seen what is the gravitational force experienced by one point mass with one bigger mass. Then what is called gravitational field intensity, the definition, the equations, and we have seen one question where gravitational field intensity is 0. Remember, like a gravitational force, gravitational field intensity is also towards the body. Okay, hope the session is clear and this is understandable to you. This is one of the part from gravitational field intensity. We have the second part of the second session for these two. Okay, thank you.